Hi all. See this, in this particular problem we definitely understand that this is a problem regarding the permutation and combination, and that particular chapter, right, it says that we have to rearrange with slum all the trickiness and all that stuff. But now come back to this problem. Now in this particular problem, right, it says that we are having a word called small, okay. So in that word small is actually rearranged. So if it is a rearrange, right, we have actually 3 to 5 letters are there, right. Inside that 2L are common, right. So therefore factorial f factorial 5 divided by factorial 2 numbers of they can rearrange. Now the problem says that if they rearrange, right, so then they have to shorten up in a English dictionary, right. So how the English dictionary works, in the English dictionary it works like that. First we'll start the word with A, then S, then M and so on, right. Sorry, A, M, S and all that, right. So the order need to be maintained through that, right. So here let us go ahead and first write that in how in the English dictionary the words comes here, right. So for this particular problem that word is small, right. So we'll say that but through the English dictionary, right, the order of the letters, therefore it's small, right. So first it will come A, then definitely it comes all the words starting with L, then M, then S, right, at the end, right. So A, L, then M and then S. So that's the order in English dictionary. So obviously now we have to find out the number of words starting with A, right. So let's consider that. So we'll first consider that number of words starting with A. Now for that let us take the first box. So this box contains A, I fixed it, and then the remaining the words will be definitely A is removed, so therefore it will be A same double L. That's it. Now therefore how many different ways this S, M, double L, right, that 4 words can be rearranged. That word can be rearranged by factorial 4 ways divided by factorial 2. Why? Because 2 2's are common. So this is the way we are required to get all those numbers. So what is factorial by factorial 2? We'll calculate that at the end. Leave that as it is. Okay. So now we'll calculate that all the letters, so all the words starting with L now. Okay. So number of words starting with L. Now here I just fix that first as L, and then the remaining will be definitely A, S, M and L. One L will be there, right? Because only one L we can consider, the remaining L will be can be changed. Okay. So here all are distinct. So therefore it's factorial 4. That's it. Now L is done. We have to go for that M. So we'll calculate that. So the number of words starting with M. For that we fix the first box as always, and now let's look for that remaining word. So the remaining word will be definitely S will be there, A will be there, M will be there, L. Okay, I just missed that. M should not be there because M is already considered, right? So S, A, double L. So here also we are getting factorial 4 by factorial 2 because 2L are present. So let's go ahead. So therefore this number will be factorial 4 divided by factorial 2. Okay. Now we have a problem because we cannot say that we cannot consider all the words starting with S, because then we cannot find that order of S, M, double L, right, that typical words. So now if we fixed with S, right, so what will be the next first word with dictionary? That should be A. So that's why we will consider that word starting with SA. Okay. So let's go ahead. So the number of words start with SA. So that's why I fixed that essay. So what is the remaining? That will be obviously M, double A, and that's it, right? So now here also it is factorial 3 by factorial 2. Okay, go ahead. Now after essay, what will be the next word? The next word will comes from that SL. So the word starting with SL, right? So let's go ahead. So the number of words starting with SL. So SL I fixed in the first position and the remaining box will be filled by M, A, L. So here it's factorial 3. So that's it. So this many words are there before we'll start the word SM. Okay. Now if I think of that, right, now we have to start with the letter with number of words starting with SM. Now if I consider that word SM, what will be the next word? Next will be A, then will be L, then will be L, right? This is the only options will be there. So we'll say that now we'll get the order of the same word small, right? So therefore we'll say the order of the words small, that's definitely equal to, we'll add all of them together. So therefore factorial 4 divided by factorial 2 plus factorial 4, then we have factorial 4 divided by factorial 2, then factorial 3 divided by factorial 2. Here I just missed that, though it's the same thing, and we have factorial 3, and here we have the word 1. Okay, so therefore we'll say that this is the number of orders. So that means if I rearrange this, right, this word or that times of that nth word will gives you the small. Now we just need to calculate this, the easiest portion. So factorial 4 is actually 24 plus 24. Now here I don't divide it by 2 because it's 2 is there. So now factorial 3 is 6, 6 by 2 is 3. Factorial 3 is actually 6 plus 1, that's it. If I add that is 48, 51, 57, 58. So therefore the 58th word will be the word called small. So that's why for this particular problem option D is the correct answer, and that's it. Hope you understood the problem. Thank you.